Hello, my name is Anubhav and I'm Solutions Architect at Cisco Systems. Today for this presentation, I will talk about Cisco Secure Firewall Cloud Native. And before we talk about SFCN, let me quickly share agenda with you. I'll start off with an introduction where I'll talk about current challenges and challenges that we'll be addressing by using Cisco Secure Firewall Cloud Native. And I'll talk about architecture, use cases, and deployment. And in the end, I'll also cover performance, licensing, and I will also share a few resources with you so that you can learn more about Cisco Secure Firewall Cloud Native. So let's start off with introduction. So today, if you deploy any architecture, first demand that you will see from customer is scalability and elasticity. Another requirements are a solution should be programmable, resilient. Current challenges with current architecture is it is difficult to scale. Config management is difficult. Monitoring and automation is also difficult. Now, if you look at all these points, if these points are not implemented correctly, your entire solution can become difficult to integrate, expensive, difficult to manage, complex, and error prone. With Cisco Secure Firewall, we have addressed all these options. So our solution is scalable, elastic, programmable, and resilient. So I'll talk about our architecture at a very high level on this particular slide. So Cisco Secure Firewall is also known as SFCN. It is today available in Amazon, and it is our scalable architecture that supports horizontal pod autoscaler. It is modular. So with this release, we have added support for CNFW, which is our containerized L4 firewall, which is orchestrated and deployed by Amazon EKS. So the entire solution is DevOps friendly. You can use YAML, CI/CD pipeline, you can use GitOps and orchestrate your entire architecture. In addition to that, Cisco provides CRDs and Helm charts so that you can deploy your infrastructure pretty easily. For config management, we support REST API, YAML, and you can also onboard your SFCN cluster into CDO if you are into UI. The other benefit that we have added with this architecture is it supports multi-region, multi-AZ, it is multi-tenant aware. And we have also added a concept of a redirector. I'll talk about redirector in the upcoming slide, but just to give you some idea, redirector is used for load balancing your VPN session based on VPN users connected to a specific worker node or enforcement point. In terms of licensing, we support bring your own license, and we have a footprint of 4 core for CNFW. In terms of data externalization, we now externalize our data. We store our VPN session information in Elastic Cache, which will give you resiliency. So in case if your CNFW is down, and one of the biggest thing that we do today is auto heal. The moment it will come back up, your sessions will be restored. Now, in May 2021, we have added support for CNFW, and it is based on ASA 916 code. Again, EKS orchestrated and deployed, DevOps friendly. We provide CRDs and Helm charts, multi-tenancy, configuration using YAML, CDO, and REST APIs. We support BYOL. And the benefit of using this particular architecture is it is really faster to provision and bootstrap your worker nodes. Now let's double click on the architecture and talk about what are the key components available in this architecture. Now I'll start from left. This entire architecture is orchestrated by Amazon EKS, Elastic Kubernetes Services, and it is multi-AZ aware. So now if you look at this architecture here, we have 2 components. enforcement node and SFCN operator, which is also known as control point. So we call it control point and enforcement point. So CP and EP for short. EP is responsible for your data plane. It processes the traffic, and control point is, on the other hand, responsible for config management, license control, and it also add routes in your environment. The moment new worker node or EP is instantiated, CP will ensure that it is stitched into the data plane. Now, our entire configuration is stored in Elastic File System, or EFS, and configuration of this architecture is done using multiple components. But when I talk about auto scale, our EPs can auto scale based on custom metrics when we have integration with load balancers as well. Now, SFCN redirector is for smart load balancing, and we couple it with Elastic Cache, where we externalize our VPN session information. Now, for configuration, admins can configure it using kubectl and YAML. They can directly interact with native Kubernetes APIs and SFC and CRDs to configure this environment. And they can also use CDO for management and eventing. So at a very high level, this is our architecture that contains EP, CP, EKS, and there are other components as well, which we'll be discussing in the upcoming slides. But at a very high level, this is what our architecture is. Now let's talk about our use cases. It is really important to understand different use cases where you can position this architecture. So we start with scalable architecture. You have seen in the recent years, there is a great spike in work from home and huge increment in remote workers. So we have been asked by our customers and partners on daily basis about a scalable and a resilient architecture that can provide secure connection back to their data center and to their application. So in this architecture, we have customized it specifically for scalable RAVPN that supports Amazon Route 53 that does the load balancing based on weighted average, and the other mode of load balancing that is known as a smart load balancing feature, where we use redirector and Route 53. And in addition to these two components, we use Redis database as well. So I'll talk about this in the upcoming slide, but the other use cases are data center backhaul. So if you have your cloud environment and you want to connect back to data center, you can definitely create site-to-site tunnels. But the advantage of this architecture is the moment new enforcement point or CNFW is instantiated, that instance will create tunnel back to your data center automatically. Multi-tenancy aware scalable cloud hub. So if you plan to move your VPN into cloud, you can do that, and then you can connect your cloud environment to your data center, to your branches, your campus, and use scalable components of your cloud and offload your scalability and RAVPN into the cloud. The other use case is scalable edge firewall as well. I've seen customers putting firewalls at the edge in the cloud to meet their compliances for NATing, access control policy. So we position this device for that purpose as well. Now let's start with a simple architecture where we talk about scalable remote access VPN using Route 53. So in this architecture, I'm just showing you a firewall side of the configuration where you have SFCN deployed in the mix, and you have your virtual private cloud with your enforcement nodes. So user on the internet will initiate a traffic for vpn.mydomain.com. This is just an example, and in return what happens is on your Route 53 we automatically add wickets for all your enforcement points. So in return, user will get IP address of outside interface of your enforcement point. When I say enforcement point, I'm referring to CNFW. Once user has the public IP address or elastic IP address of your enforcement point, user will connect directly to that enforcement point. Now, thing is, for each CNFW, we have a dedicated VPN pool so that we can automatically add routes in the entire VPC. So whenever a new EP is instantiated, we automatically add it to Route 53. We create a wicket for it. We assign public IP address to that device. We enable monitoring on Route 53 for the new CNFW, and we also ensure that routes in the route tables are added accordingly. So you don't have to worry about all these items. The moment new device is instantiated, all these complex configuration is done automatically by Cisco Secure Firewall Cloud Native automation and orchestration. Now, we have seen customers asking for a scalable architecture where they would like to load balance traffic based on matrix, different matrix rather than weighted average. So we did some research and we came out with this architecture where user will send request for vpn.mydomain.com, and in return, instead of IP address of enforcement point, user gets IP address of SFCN redirector. Now, what SFCN redirector is? It is another CNFW, but it is only responsible for redirecting VPN traffic. Now, the CNFW consults Redis database. Now, Redis database has information about all the enforcement points and which enforcement point has the least number of sessions. Redis database will provide that information to redirector, and redirector will in return send that information or public IP address to the user. Now, user will make connection back to CNFW. So by using this architecture, we have solved two problems. Instead of using weighted average load balancing, which is not a good method of load balancing for VPN session, because VPN sessions are long-lived sessions, and we have also added externalizer data in Redis cache. So imagine you connected to EP2 and something happens to EP2. So now the moment EKS will see that one of the EPs is down, it will try to auto heal it. Within a couple of seconds, the new EP will come back up. The user will then connect back to the same EP, and user will not enter the username and password because that session information is already stored in elastic cache. Now, on the orchestration side, whenever a new EP is added to the architecture, it is added in the redirector, it is added in the Route 53 as well. Health check for CNFW is enabled. Elastic Cache keeps track of all the VPN endpoints connected to each CNFW. VPN session is done based on VPN counts on an EP rather than weighted average. So all the automation and orchestration is handled by our architecture in the backend. So whenever a new EP is added, new EP will get its own dedicated VPN pool. Routes will be added automatically. New EP will be added in the redirector. Information about new EP is also shared with Elastic Cache, so that Elastic Cache can provide information on how many VPN users are connected to each EP, and then SFCN redirector will load balance traffic based on VPN sessions. The other thing is that we have seen is how can I connect back to my data center? That is the biggest question when we talk about deployment in cloud. So there are multiple options, but in terms of automation and orchestration, what we have done in this architecture is the moment we instantiate EP, you have options of providing configuration of your DC backhaul as well. So the moment you instantiate a new EP, your EP will form tunnel back to your data center as well. Now in this example, if your user is connected to enforcement point A, you have a tunnel, and if your user B is connected to another EP, there is another tunnel. So that way, the moment we instantiate our EP, we also instantiate tunnel back to your data center. So this provides a scalable architecture for DC backhaul as well. So all the automation and orchestration with new device is done natively by this architecture, and you don't have to worry about adding routes. You don't have to worry about adding VPN configuration. You just need to put everything in your YAML configuration, deploy it, and once it is deployed, the newly instantiated CNFW or enforcement point will automatically pick that configuration. Now, another big ask from customer is multi-tenancy. Is your architecture multi-tenancy aware? Yes. Answer to that question is yes. Cisco Secure Firewall Cloud Native supports multi-tenancy using cloud native constructs like namespaces. So if you have a use case where you want to deploy RAVPN architecture for multiple customers, you can definitely use this architecture, and you can use namespaces to segregate. And there are other things like subnets, security groups, route tables that will segregate your traffic. So for example, in this diagram, what I've shown is you have tenant namespace A and you have tenant namespace B. And in addition to that, you have connectivity going back to their respective data center and their cloud environment. So you can enable multi-tenancy. Scalable hub is another important thing. If you want to push your VPN into cloud, you can do that. And then you can have a transit gateway or some sort of other device that is capable of doing IPsec. You can place Cisco CSR routers and connect back to your data center. So in the cloud, on the north-south, you will have SFCN providing you RAVPN capability, which is scalable, resilient, automated architecture. And on the other side of that, you will have connection going back to another VPC or your data center, or if you have other cloud providers as well, like Azure, GCP, OCI, you can connect back to those providers as well. Now, this is another example where I have firewalls at the edge. I'm using this firewall for auto scaling, auto healing, access control policy, NAT, load balancing. So these are key use cases if I just want to use it as firewall. Now let's look at our deployment. So first of all, I'm going to be sharing this link in description of this video as well. But if you go to SFCN-AWS-listing, if you go to market container listing in Amazon Marketplace and you search for Cisco Secure Firewall Cloud Native, you will see a quick start that we have recently added. That quick start will install your base infrastructure. So there are three options when you deploy it. Install in a new VPC when you have a greenfield deployment. If you want to add something to your existing VPC or SFCN to your existing VPC, you can use install in an existing VPC. Third option is if you want to add another tenant into your existing installation. If you're using this architecture for MSSP use case, you can add a tenant later on as well. You start with one tenant, later on you decide to add another tenant. You can probably you can use our quick start to do that orchestration for you. Quick start will build base infrastructure. It will create your EKS cluster. It will create your SFCN redirector and Redis cache. It will configure your Route 53 and hosted zones, which is pretty big. So you don't have to worry about how will I integrate each piece together. It is automatically and automagically done by our quick start. Now, this release covers deployment of CNFW, which is purely for VPN, but you can use it for firewall at the edge as well. Management, configuration and monitoring is really important to understand. So if you position this architecture for customers who are into infrastructure as code, definitely you can talk about kubectls, REST API, CI/CD pipeline, YAML files, GitOps integration. And if your customer is into UI, once your cluster is built, you can onboard it directly into CDO and use CDO for your configuration and monitoring. So this is what we have at a very high level. So just to show you a few steps, this is a listing. You can go there, read more about our product, read about our scalable architecture, about pricing, usage, support, and then you click on subscribe. Once you're subscribed to the software, you can click on continue to configure. Now at this point of time, you will decide what kind of deployment is it. So in the delivery method, you'll be choosing CloudFormation Quick Start, software version 1.0, and then you will click on continue to launch. Now this is what I was talking about earlier, deploying this device in multiple places. So you can use it for new VPC, existing VPC, or add a tenant to existing installation. So for example, if I click on install in a new VPC, I'll be presented with a quick create stack page where I'll define my stack name. I'll give my SSH key. I'll give my user URL. Really important, this user URL should have admin access to deploy EKS. It should have admin access to deploy your EC2 instances. It should have admin access to deploy route tables. So you just define your user ARN instead of username. Now, then you will decide your information about control plane and data plane. So control plane is CP and data plane is EP. So in this example, I have given my minimum node for CP is 1, maximum is 2. I can start with minimum 2 and maximum you can add whatever number you want. We have tested around 75 enforcement points. So in this example, I'm just starting with minimum because this is just a demo slide. So I'm just starting with minimum 1, maximum 5. I define elastic IP address. Now, why this elastic IP address is required? I'm assigning elastic IP address to both interfaces. That means that I'm assigning it for inside interface and outside interface. Outside interface elastic IP address will be used for terminating my VPN sessions, RA VPN sessions, and inside elastic IP address is used for termination of site-to-site tunnel back to my data center. So I have enabled both. Cache type, here I can select none if I don't want Redis database, but if I want Redis database, I will select elastic cache. Now on the enforcer installation, I'll select enable. Enforcer rule, if I want to enable redirector capabilities, I will select default and VPN redirector. I will enable auto scaling. I will give a token. So by default, if you don't give a token here, your cluster will have one enforcement point, and that enforcement point is restricted to 100 kbps. But here, since I'm deploying multiples, I'll be deploying multiple enforcement points. I've given a token as well. So if you don't have token, you talk to your sales executive or sale account team at Cisco, they'll provide you a test token for 60 days. You can use that token and deploy and test this device. In the Kubernetes version, I'm keeping it at default 1.18, and the additional EKS role is optional. Since I'm using my admin role to deploy this infrastructure, I've left it as at default. Clustering logging type, I can define multiple places where I can log in, so I'm just not enabling logging for this particular deployment here, so I'll just leave it blank. Now this is a really important place where you define size for your infrastructure. So I'm using 4 vCPU instances. I have specified elastic cache size as well. And now in the Redis token, I need to enable in-transit encryption. If you will not enable that, your deployment will fail. This is the hard and fast requirement. So you enable in-transit encryption if you have elastic cache. Then you will define 16 to 128 alphanumeric character password for your Redis authentication, and you will define a key as well, which is 64 uppercase hexadecimal number. So make sure you define these 3 items, and then you specify your namespace. In this example, I'm using SFCN dash namespace. Now on the CIDR range, if by default we have 10.37.00/16, if your customer has a network that overlaps with this range, you can define your range accordingly. You can this complete quick start will deploy multiple subnets, and along with this video, I'm going to be adding an end-to-end deployment demo as well that covers what subnets will be deployed. But at a very high level, we deploy public subnet, private subnet, inside subnet, and outside subnet. 4 subnets, and one more subnet on EP, so that it can talk to CP using management interface. So that is covered in that architecture. We'll couple this introduction video with the demo video so that you can refer to the end-to-end deployment video as well. Now, once you have defined everything, leave the other options like quick start bucket name, S3 key prefix, and bucket region as default, and then at the end click on those 2 check boxes and click on create stack. This is how you deploy your infrastructure. It'll take somewhere between 15 to 25 minutes to bring up your entire architecture, and time may vary. If you plan to deploy Redis database redirector, the time may vary, but somewhere around 15 to 25 minutes it will take to deploy complete architecture. Once your architecture is deployed, next question is how will you configure your SFCN infrastructure? Answer to that question is really easy. You can straight away, once we deploy that stack, we straight away provide you information about CDO token and your API point. You can simply use that and onboard your device into CDO, or you can use kubectl and YAML. In the resources slide, I have information about our GitHub repo as well. Now there are a few samples that I wanted to share with you. So these are the sample files. You can download these sample files from our GitHub repo. So these are sample files for deploying interface. Then we have sample file for deploying network object. We have another sample file for deploying access control policy. We have a sample file for deploying end-to-end RA VPN architecture for you. So we create things like file objects where we'll post our RA VPN profile, our images, then we create CLI for deploying entire VPN for your SFCN architecture. So these are few files that is there in the GitHub repo, and we'll share those links as well in the resources. So you can go to our GitHub page, download these YAML files, look at our CFT, look at our quick start, and then you can deploy your devices. Once your infrastructure is deployed, you can definitely log in using CDO as well. You can onboard it into your CDO, and from there you can manage your SFCN architecture. Now, in terms of performance and instance type, we support M5 large instance for CP, EP, redirector, and even for Elastic Cache. Elastic Cache is default at M5 large, but you can definitely go ahead and use bigger one if you have a lot of VPN users connecting to your environment. And information about how to choose Redis database will be added in the datasheet. Now on the VPN IPsec throughput, we have 1.5 gig of throughput per enforcement point, and we have tested up to 75 enforcement point in one cluster, and that can provide you throughput in hundreds of GBs on IPsec, which is pretty huge. And per EP you can have 2000 VPN endpoints. It can be your side-to-side tunnels or RAVPN users connecting to your environment. Now, in terms of licensing, we start with a 4-core EP, and these licenses are based on cores used by your SFCN cluster. There is a component within the architecture which is known as license controller. You don't have to worry about complex license calculation. It is done automatically by license controller. License controller talks to Cisco Smart Licensing and provide you licenses for your enforcement points. If you have MSSP use case and you have multiple tenants, we support that, and we support multi-tenancy licensing as well. So for example, you have a smart account where you have hundreds of licenses added, and you have 2 tenants consuming those licenses. So you can configure your SFCN architecture in such a way that your licenses are picked for each tenant separately. On the AnyConnect side, licensing model is same as ASA. There is no change. And if you don't have license on your EP runs at 100 kbps. If you want to test anything, you are still okay to deploy this architecture, test it, but throughput will not go beyond 100 kbps. There is a rate limiter in place. Now resources, these are few resources. We have our SFCN page, SFCN at a glance. We have a technical blog. I wrote a technical blog a couple of weeks ago where I talked about our entire architecture, traffic flow, key components in this architecture. Feel free to refer to that blog. There is a business blog as well explaining key business values for this architecture. We have marketplace listing. We have GitHub link as well. And this is our quick start architecture. We'll start with right hand side. We have Route 53 responsible for RAVPN. Then we have Elastic Cache for data externalization. We have Amazon EKS for management of this entire Kubernetes cluster. And then we have Lambda functions for different operations like instantiating device, adding the device into Route 53, adding routes, those kind of things. And then we have auto scale group for CP, and you can auto scale your CPs, your EP, and in this example you can see for EP we have shown 4 interfaces, management inside and outside, and there is another management interface that connects towards CP so that CP can talk to EP. There is a redirector as well in this architecture, and redirector is responsible for redirecting your VPN sessions in a smart way rather than just doing a weighted load balancing. You can refer to Redis, find out how many VPN users connected to each EP, and redirector will send new connection to the least used EP so that your sessions are well organized and well redistributed. So this is what I had in this introduction video, and I hope you enjoyed this video. Thank you for watching.